All right. Hello, everybody. Welcome back to another session. So you are in laying the foundation, real-world Kubernetes deployments. My name is Josh, and I am an employee of VMware. I came over from the Heptio acquisition. Prior to VMware, I worked at CoreOS for about a year and a half, so I've been doing Kubernetes stuff for quite some time. My focus around Kubernetes is working in the field and working with a lot of different customers who have a lot of different deployment strategies around how they're going to roll their Kubernetes. So this talk is going to be a really interesting kind of, I guess, retrospective of a lot of the collective experience that Craig and I have had working with many of these customers, some of the really great patterns we've seen, and some of the areas where we've seen folks cut themselves a bit on some of the sharp edges that we see in the Kubernetes ecosystem. So again, I'm Josh, and this is Craig.
Yep, I'm Craig Tracey. I'm also a staff field engineer at VMware, came also through the Heptio acquisition. Primarily, I'm based in Boston, go Bruins, and primarily working with customers in the New York City area. We're talking like Fortune 100, Fortune 50 banks. So there's a lot of opinions about Kubernetes. Some of the opinions are somewhat hysterical. I love Paul Zar's tweets all the time. If you don't know Paul Zar, you should definitely follow him. He has some great hot takes on technology, especially Kubernetes. But what you'll find if you look for opinions about Kubernetes is that a lot of them are somewhat critical of how hard Kubernetes is, and I think a lot of them are expressing some frustration with how hard it is to actually get Kubernetes deployed and operable. But I think when all said and done, Kubernetes is actually not that hard. There are ways that you can look at the patterns from successful customers, and as Josh pointed out, some of the less successful cases. In this talk, we're going to try to give you some examples of the way most customers approach Kubernetes, where they start to trip up, and what types of problems they have. We won't go super deep technically, although at the end of the presentation, we did set aside some time for questions. If you want to go deep on technical stuff, we can go deep there. We only have 35 minutes, so we want to hit the high points. The first thing that customers struggle with is where are we going to put this Kubernetes cluster or their clusters? There are a variety of choices, as you may know, and we'll walk through each one of these and kind of talk through some of the advantages or disadvantages of each. The first, obviously, is managed Kubernetes. Here we're talking about the AKSs, the EKSs, the GKEs of the world. And these platforms are really great. They provide an easy turnkey solution for customers to get up and going with Kubernetes. It's in a managed environment. But this comes at a bit of a price, right? So you don't typically have access to maybe all the things that you need. If you have a compliant workflow or a compliant application that has to adhere to specific security constraints, you may not be able to deploy here. So an example of this would be when you get to a lot of these managed Kubernetes platforms, you don't have access to the control plane. Maybe you need access to etcd or access to audit logs. That's not something you typically get with a managed Kubernetes offering. The second area that you might explore is something like a distribution. So there's things like PKS or OpenShift. And what this requires is that you have a little bit more of a team, perhaps a couple of operators that can help manage the distribution. And they give you a little bit more control. Now you have access to things like the control plane. But you may not have access to all the features. And I'd say that's one of the areas where distributions start to fall apart is, if you're constrained tightly within the box that a distribution offers, then things are great. As soon as you start to stray a little bit outside of that realm, things may start to break down for you, and things that you may require may not be supported. And of course, the third area that, this is the area we're going to focus on in this talk, is rolling your own. What does it take to roll your own? Obviously, it's going to take more person power to make that Kubernetes cluster happen. You're going to have deep insights in how the community is moving, like which directions they're moving, what does a cluster lifecycle upgrade strategy look like, these sorts of things. It is not as hard as most people make it out to be, but there are things that you're going to need to know.
So talking a little bit about some of the missteps that we sometimes see with our customers when working with these different Kubernetes deployment models. One is a lot of times we go out to customers and they are very focused on going all in with managed Kubernetes. Now, managed Kubernetes is extremely awesome, especially conceptually. Who here is very excited to not manage their control plane at some point in the future? Show of hands. Woo! Yeah, we are psyched, right? However, sometimes we get so all in with this, we don't really take on or are honest with ourselves about the cons that some of these services do have. An example as far as costs that are associated with someone else managing your cluster, I don't necessarily mean monetary costs. I mean some of the things you're going to have to take by not having access to perhaps the control plane. As an example, I was working with a customer at one point where we got really far down the path of using a managed service, only to find out after many months of effort that since we didn't have access to the control plane, we couldn't turn on pod security policies. And that caused a ton of rub with the security team and what they were trying to do with their multi-team, multi-tenant clusters. So kind of looking through some of those trade-offs, it's kind of like a Roomba, right? Like delegating your vacuuming to a Roomba is awesome, but if it snags your toilet paper and drags it all around your house, you need to think like, am I cool with my toilet paper being dragged all around my house? Maybe I could raise my toilet paper a little bit higher. Maybe my toilet paper is not a concern for me, right? So it's just those things you have to be honest about. There's trade-offs with everything, of course. We all know this super well, but this is included in managed services, and we really need to consider these types of things. And then another thing we run into folks cutting themselves on quite a bit as far as the sharp edges is having a one-size-fits-all tool that does everything from start to finish, right? So I click this box, I hit OK, and then boom, my infrastructure is there, everything's configured, and Kubernetes is installed and running. And if you're using like an enterprise fully baked offering, that's great because you have someone to support it and so on. But when you take on one of these one-size-fits-all installers in the community, I think there's definitely some considerations you kind of have to make, right? One is that the infrastructure that you're using is probably different. If you look to the left and to the right of you, assuming you're not sitting next to your coworker, they probably have a very different setup than you currently do, right? And trying to make these installers fit that model of our very unique infrastructure, it's not that easy to do. And then another thing that folks don't oftentimes consider is, are you comfortable with supporting this thing? Again, if you have a vendor backing you, that's awesome. You can go to them if something's wrong or you need to get it fixed, that's great. But if you're using an open source offering, do you treat that tool like a big black box with a couple knobs in front of it, right? And if you were to go home right now and turn some of those knobs, do you know what those knobs actually impact? And another thing that we run into quite a bit when you don't actually understand the pipeline that builds your clusters is you can get yourself in really weird situations when, crap hits the fan, right? Like a run C vulnerability comes out, and now all of a sudden you have to roll updates throughout your entire cluster, but you're really not sure how the update structure works. You've just kind of run it in the past. It's been okay. Like it's kind of sort of worked. But if something breaks in that big black box, big machine that's updating your nodes, you might be in a bit of a sticky situation. And sometimes we actually advocate for our customers to consider smaller, more purpose-built tooling, right? Where they understand the config management, perhaps. They understand the infrastructure provisioning. Now, there's trade-offs to that, because guess who has to own that? You, right? But if you know how it works, you can better enable yourself to handle those intense situations should they come.
So when we engage with customers, we like to first talk about some very high-level principles. These are the things that you should be thinking about as you approach Kubernetes. The first thing we work with customers on developing is a plan for how they get to what their ideal state is. And a lot of customers will approach us and say, like, they get very locked into these design decisions up front, saying, okay, well, I'm thinking about ingress, and I've decided that this is the right ingress controller for me. The nice thing about Kubernetes is you don't have to do that for the most part. You can decide what's right for you today and what's right for you down the road. So oftentimes we'll work with customers and they say, today Nginx ingress controller will work fine for us, and that's great. That gets you to production sooner. You may find that down the road that something like Contour or one of the other ingress controllers would be better suited for you. Kubernetes, because it's declarative, we can declare a state and say, okay, today our ingress controller is Nginx, and then 6 months, 8 months, 12 months down the road, it's going to be something different. So don't get hung up on the details of what your actual deployment looks like. The other thing that folks will tend to do when they approach a Kubernetes deployment is like, okay, we're doing this Kubernetes thing. Everything's greenfield. We're going to start from scratch. We're going to deploy Spinnaker or whatever new tool is out there today. And that just typically does not work. What you want to do is find the integration points with the tools that you have today. So let's say you have Jenkins. That's a perfect tool. Use Jenkins to deploy the applications to the Kubernetes cluster in a way that makes sense for your users. And speaking of users, enable your stakeholders. You wouldn't believe the number of times we work with customers where they forget about the end users. So depending on the organization you work with, you may have a small DevOps team, but you may also work in a large enterprise that has separation of concerns. So you may have a group of operators that are responsible for the uptime of the application. This is a pretty typical pattern. And I've worked with customers where, the typical operating pattern is, okay, something breaks with the application in production, I'm going to SSH into this box and find out what's wrong. Now that you've, in a containerized or a Kubernetes deployment, right, typically you're going to do something like log aggregation and push those logs off to a separate system, maybe Elasticsearch or something like this. Make sure that you're enabling your stakeholders, give them the access that they need to be able to look at those logs, and also the same sorts of controls that they have. So like another area that you might trip up on with something that looks like log aggregation is like, how do I do role-based access control against logs? These sorts of things are critical to your deployment because at the end of the day, the number of stakeholders who are bought into Kubernetes will significantly affect your success rate with deploying Kubernetes in your organization.
Cool. So on the front of principles, one of the things that we run into quite a bit, and I'd say these two are probably some of the most common things we run into with our customers, are a desire to prematurely optimize, or maybe to say solving problems that you don't yet have, right? So this is interesting, right? It's like you go to a car dealership or something, and you look at one package of car, and then you just kind of talk yourself into the next package of car and the next package of car, when reality is you just needed something to commute you 2 minutes every day, and you end up with this, $80,000 crazy vehicle, right? A lot of our customers fall into this trap. One of the really common ones that we've seen, at least over the last year, is the idea of whether to use a service mesh, right? So all of you in this room, right, who have run microservices or are thinking about it, you can conceptualize the problems that service meshes solve. It absolutely makes complete sense. In fact, it's fantastic. Why would you not want a service mesh? You'd have to be crazy to not use one, right? However, do you actually have the problem it's solving for today? Or are you on the cusp of actually needing to solve that problem? A particular customer that we worked with decided, our Kubernetes isn't quite operationalized. We don't really understand it that well, but we can totally tell that we're going to need service mesh, so let's just add this on now. And then spent the next 6 months figuring out that not only was the technology they chose not quite ready because it was still in the early days, but also they added so much complexity to their system to solve problems that they didn't necessarily have. To Craig's point, they weren't solving business value immediately, and they created a fragile system that was delaying the deployment to production of their Kubernetes infrastructure. So it's really thinking about, what problems do I need to solve? What problems do I have? And that kind of leads into the next one, which is perfect is the enemy of done. So another show of hands, who here is in the planning stage of Kubernetes in their organization and is thinking about rolling Kubernetes out to production at some point in the future? All right, those of you who have your hands up, please, please, please don't try to boil the ocean and build the most perfect thing from start to finish, right? We run into this all the time, all the time. Think about, how can I add business value early on? Getting a Kubernetes cluster up and running, even if it's slightly naive, it's so valuable to get some operational experience around how it runs. If you're new to Kubernetes, welcome. Very glad to have you. But you have so much to learn, right? And don't just waste all of your time cycling through perfection, only to realize that there's a bunch of problems that you're going to need to solve for that you could have learned about had you gotten an MVP-like thing up and running. Maybe just a couple workloads, rather than trying to shift your entire organization over to this brand new, beautiful, perfect platform. Because chances are you're gonna predict a couple things wrong if you go all in like that.
So we talked previously about the nice thing about Kubernetes is that it's composable. You can declare state and have multiple technologies running in parallel. There's some areas where this is not true, right? So there's some things you're going to want to think about up front. You're going to want to get these things right. The first is container networking. You should choose the container networking plugin that's right for you. There are various options out there. So if you look at something like Calico, the nice thing about Calico is it provides normal Linux networking. It scales pretty wide, but it maybe doesn't come with some other features, like for instance, if you need something like hard multi-tenancy. That's an area where something like maybe NSX would shine. You may have a requirement for something like multicast. A lot of the CNI providers do not provide support for multicast. You may need also something like hardware offloading of NICs. And again, most CNI providers do not do that. The second one is persistent storage, and you would be shocked at the number of times we approach an engagement. This is an on-premises engagement, and customers have not thought about storage. I think it stems from the fact that the customers that we engage with are typically trying to deploy an application. They've elected to take on Kubernetes, and part of the reasoning, I think, is that they don't want to talk to central IT about getting storage. So they don't think about storage. So we go into these engagements, and all of a sudden there becomes an immediate need for storage. And then we're talking about things like Rook or OpenEBS, and how do these things scale, how do these things perform. So definitely give a thought to persistent storage before you approach an on-premises deployment of Kubernetes. And the third area would be connectivity. So they have their applications, they deploy these applications, let's say they're even stateless, and they go to create a service type of load balancer, or they deploy an application that plumbs through an ingress controller. Then they realize, oh wait, we don't have a load balancer on site. So think about these things. Make sure that you have the appropriate infrastructure that surrounds Kubernetes to support your deployment.
We have a clicker battle going on. Okay, so what are the common missteps with Bedrock that we see? So this is a really, really common one. Trading battle-tested for cutting edge, right? If you think about the CNCF landscape slide for a moment, right? You'll probably get nauseous because there's so many graphics on that CNCF landscape thing. There's so much awesome movement in this community right now. And we're kind of like the Lara Crofts and the Indiana Jones of the CNCF landscapes, right? We're trying to navigate and adventure around the crazy amount of projects that are out there. And my experience has shown, hopefully you have a similar experience, that folks are very, very quick in this community, in this industry, to wake up in the morning, see a new project on GitHub, and be ready to bet their entire business on it, right? That's a really, really rough model. We've seen people try it, and sometimes, and if your team is, extremely, extremely capable engineers who understand the project, that can work, but you're taking on a lot of risk, right? So when you see that new CNI plugin come out, when you see those new things, I'm not saying don't use them. Keep track them. There's a lot of really interesting, especially in CNI, there's a lot of interesting stuff going on with eBPF and all this stuff, right? But there's a lot of projects that have been around for a really long time that have been doing the job super, super well, right? And again, this is your bedrock. Do you want tons of instability or unknowns in your bedrock for a couple new features that you think are really cool? So you've got to balance that out when you're thinking about this stuff. And then lastly, and we probably all know this super well, open source is certainly not free, right? It requires diligence. So a lot of times we're trying to help our customers navigate whether they should adopt an open source project. And I'm sure a lot of you go through the same thing in your organization, right? Like, I need to do IAM authentication in AWS. Do I use KIAM or do I use Kube to IAM? What are the differences? What is the project health? And while it might seem kind of silly, genuinely gauging the community health of something that you're trying to take on is an extremely valuable tactic, right? Going on the GitHub page, and obviously stars are all you'll need to check, right? But yeah, thanks. So yeah, so stars are really important because it'll show some traction in the project. But more realistically, if you go into issues, right? Are the maintainers, is the community responsive, helpful, right? Are pull requests getting reviewed and merged and considered? Is there guidelines for how to contribute, or is it just a README with like some Go code and who knows what's going to happen, right? You really want to look into this stuff because, again, these are technologies that you're potentially betting your business on, and it's really valuable to have a gauge for what level of risk you're going to take on with the health of that project over time.
All right. At the end of the day, you own your uptime, right? So the other area that people often overlook is the security model around what their Kubernetes deployment will look like. And when we were at Heptio, we kind of came up with this idea of multi-team versus multi-tenant. I think it's a really powerful one. The way that we think about it is multi-team would be perhaps like the same organization. You have a certain level of trust between members of your same organization versus multi-tenant, where you are taking some random people from the internet, placing them on a Kubernetes cluster together. There are different design constraints you want to think about when it comes to security, for sure. And a lot of folks overlook this point, especially with regard to things like how I perform builds on my cluster. Let's say I'm using my cluster for performing some Docker image builds. This is something you're definitely going to take a look at. By and large, Kubernetes does not have a hard multi-tenancy design, and you can certainly enable those sorts of things, but it doesn't come out of the box. The next thing would be consistent authentication and authorization. You would probably not be surprised at how many folks we engage with that they've used something like KubeADM or another tool that spun up their cluster and then spits out this X509 certificate, and then that person then goes and mails it to the rest of the team for how they're going to access this cluster. That's the wrong way to do it. Use something like OIDC and connect your existing user federation systems to Kubernetes. It's actually really simple, and it enables all sorts of other things that will relate to policies. Policies are the next area that people forget. They go off and they deploy their Kubernetes cluster, and the number of times we see people that forget about resource quotas or pod security policies is like pretty much every single cluster. These are the things that are both going to secure your cluster as well as give you the levels of utilization that you want in your cluster, and we'll talk about that in a little bit, a couple further slides. And the final one will be backup and restore. At Heptio, we built this tool called Arc, now known as Valero. It's a great tool for both making sure that the applications that you deploy to Kubernetes can be moved to different clusters if you encounter a situation that a disaster situation where you have to move clusters. It can also be used for things like CI/CD workflows or just basically Xeroxing one namespace or a collection of resources from one cluster to another. So I would definitely take a look at it if you haven't already. It's a very powerful tool that we have added to the community.
All right, so missteps that we see in security, and this is definitely one of the highest friction points, quite frankly, that we run into with our folks. So a lot of times there's this desire when thinking about Kubernetes as a piece of your platform for orchestration, right, is to have this one mega cluster that rules them all, right? And when we start out, especially those of you who are just getting started on this journey, right? You're going to start out and you're going to start onboarding workloads, but then these workload requirements are going to come on that are going to require some things you perhaps didn't think about. Like when someone says, all right, I got a workload. It needs to be, it needs to be conformant to PCI. Make me a namespace that's a PCI namespace, right? And if you try to engineer this, it is really hard to do, right? Not to mention if there's some other obscure requirement that you may or may not want to introduce to the entire cluster for one workload, but you don't want to necessarily say, absolutely no Kubernetes, stay on the mainframe forever, right? But you don't want it to kind of impact your entire initiative. So thinking more about when does it actually just make sense to start stamping out clusters for our folks? And with managed Kubernetes service offerings, hopefully this will become even easier. But when you have these more edge cases or maybe security requirements, it's not necessarily a bad model to stamp out a more secure cluster that has other considerations. I mean, we've been doing this forever, right? Like if you're a bank, you segregate the info, the stuff that requires additional InfoSec stuff outside of the more general stuff, right? To ensure that you don't lose agility in the more general stuff, perhaps. And then this is one that you'd be surprised how much this happens, but not getting your security team involved early, right? Show of hands, who would say they work primarily in the security realm at their work? Okay, those of you who raised your hands, thank you for being here. We're so psyched to have more security-focused people in the Kubernetes community. But this is something that we find really interesting because a lot of security teams that are out there, they don't really know that much about Kubernetes. Sometimes they don't know anything about containers for the most part, right? We're starting to see that shift change, but you have to keep in mind that this isn't just a journey for you, right? This is a journey for your security team. This is a journey for your apps team. You have to bring everyone along with you and make sure that you're keeping people up to speed. And honestly, if you're the operator of these clusters or the person architecting them, you're gonna have a lot of education on your hands, right? And that especially goes with security. You wanna make sure that it's not the 11th hour and security is going, oh, what do you mean containers can potentially run as root, right? That's the last place you wanna be. And that leads into our last point here, which is bringing them on early so that security isn't something you just try to bolt on later, right? Like our this is fine dog here, right? Run as root, true, and I'm okay with the events that are currently unfolding, right? So you can see how this can be really, really messy over time. And show of hands, who's tried to add pod security policies to a running cluster before? All right, I'm so sorry. Wow. That is arduous, to say the least. Who's tried to add network policies after the fact when there was no network policies in the cluster? Whew, wow. That's crazy. So we know that when you change the security posture, when you change how your cluster works from a security standpoint, it causes a lot of headache to many developers. Now there's ways to ease this a little bit, but let's be honest. Like the last thing you want to do is insert a network policy in a namespace, and all of a sudden that allow all rule that your developers were used to inverses to a deny all, and then only things that were explicitly allowed are allowed, right? That's a big model change. You don't want them to be submitting their containers they've always been submitting, and all of a sudden it says, sorry, but you're running as root. And then they're blocked all of a sudden, right? And they're looking for a new Nginx image because the Nginx image runs as root. You can see the headaches that this causes. So moral of the story, bring security along with you during this ride, during this transformation.
And then we also work with customers about how they're going to scale out their clusters. This oftentimes comes early in the conversation, typically in the sales cycle. We have customers who come to us, and we've had customers that say, we're going to build the 2,000 node Kubernetes cluster. And of course, you can look at the community benchmarks for the Kubernetes clusters and how big they will scale. I can promise you that 2,000 is an inappropriate number for scaling out Kubernetes clusters. The nice number that we like to work with, I think, is around 500 nodes. And at 500 nodes, that's where you're going to start to run into issues around having to actually tune the components of Kubernetes. So if you don't want to start to tune Kubernetes, which can be an arduous process, I'd say around 500 is the number of nodes. But you want to be in the multi-cluster mindset anyway, right? So we talked about features before that you're not going to change, things like CNI networking. Maybe in 6 months' time, you may say that there's a new CNI provider that we want to use. If you have a multi-cluster mindset, you can easily snap out new clusters and migrate workloads to new clusters. Then, of course, when we talk about multi-cluster, the question always arises around federation. How am I going to have a very seamless integration with my app deployment? How am I going to say, this application needs to be deployed to US East and US West for redundancy's sake? By and large, we would advise against using generic tools for federation. These tools are generic. They probably don't fit your specific business use case. And there are other ways to do it. So implement things like Jenkins workflows or pipelines to get your applications to the places that you want them to be with the business rules that you can apply. We had a project called, a SIG called SIG Federation. SIG Federation was actually disbanded for SIG multi-cluster. And there's a reason for that. This problem is really, really hard. Solve it with the tools that you have in your in-house today. And then we talked before about resource policies, things, especially around quota. A lot of people approach Kubernetes with the desire that they want to increase utilization of their infrastructure. So maybe previously you were scaling your application at the EC2 instance layer. Now you can scale with a container. But to do this, you have to implement resource quotas, right? You need to make sure that one consumer of your cluster is not overtaking the cluster. It's going to help you actually do tighter bin packing on those instances within your infrastructure.
Cool. And this one's pretty short and sweet. So one of the missteps we see, kind of going along with what we were just talking about with stamping out clusters, is folks who try to bootstrap mega clusters, let's call them, right? And you can have big clusters that run large workloads, especially as you get more and more Kubernetes operational expertise. But if you put all your eggs in that basket and then the train shoots off the rails, you have a big blast radius there that you have to worry about. If you have one control plane that's managing all of your workloads inside of a single cluster, that's really awesome that you got there. But the blast radius, if someone starts taking a hammer to things, is pretty large there, right? So generally, we just, again, want you to consider the possibility of running smaller clusters, not just for security reasons, but also for what Craig's been talking about being able to slice things up, handle multi-tenancy in a cleaner, easier way than you'd otherwise have to engineer purely with a large cluster with many namespaces inside of it.
Yeah, we missed that on the multi-tenancy piece. This is a very common use case where folks maybe have a super secure or super compliant application, let's say PCI workloads. If you're already in the mindset of building multiple clusters, right, that's a perfectly fine tenancy model. You can get around some of the hard tenancy models within Kubernetes itself through namespaces by just deploying additional clusters. And you should plan to extend Kubernetes, right? So a lot of folks that we encounter, they see Kubernetes as this thing, I apply some YAML, and an application comes out the other side, somehow deployed. They don't really understand the mechanics of how that works internally. But it's actually not that complex. Through things like custom controllers and custom resource definitions, you can define your own types. You can add functionality that may not exist in the community. A perfect example of this is if you have an existing legacy infrastructure, let's say EC2 again, and you have some form of service discovery there, let's say DNS, how do I now reflect the new model with Kubernetes into this existing service discovery model? We've seen a whole host of ways that people do this. Using a controller or an operator to do something like that is a really simple way to do it. It's not that hard. You can write it in any language that you want, and it's a really good way to move forward. So every customer that I've worked with has extended Kubernetes in some way, whether it's something like deploying Calico, where Calico comes with CRDs and they don't even realize that they've extended Kubernetes, all the way down to, in fact, most cases that I work with, customers are actually building their own operators for their very specific business use cases. So you should plan on that. You should look into operators, see how those would potentially benefit your deployment.
And the misstep that we most commonly see with extending Kubernetes is when you kind of do that smell test, and it seems like the extension point isn't so Kubernetes native, right? So, a lot of us, I'm sure there's a lot of Go programmers in the room. A lot of us learned how to write good Go by looking at the standard library, right? A lot of us can learn a lot about extending Kubernetes by understanding how Kubernetes itself works, right? An example that I can give you is, this is a real life example. Say you have a service discovery situation, and we've walked into customers before where they needed to articulate that some pod was up to a service discovery mechanism, and the method that they did that was they set up in a init container. The pod came up, the init container said, okay, the pod seems, I guess the init container came up first, said, okay, hey, pod information, go to service discovery, shot that up to service discovery, and as you can imagine, while that does work, it's pretty fragile. You end up with a machine that looks a little bit like this, right? Something knocks something over, knocks something else over, and if something goes wrong in that chain of command, then you could get yourself in a bit of a sticky situation. But when you look at the Kubernetes kind of primitives and the way in which Kubernetes works, you think about things like reconciliation loops and eventual consistency. And how can you kind of take that same model and move it into there? Well, it'd be pretty easy to just have a very small controller, a couple lines of code ideally, or many lines if you make it advanced, that just kind of goes through and understands when these things are coming up and then updates service discovery accordingly, right? That's a much cleaner, easier to troubleshoot method. So just be sure that you're doing a bit of the smell test when you're extending Kubernetes, and be sure that you're not going completely off the rails as far as building really complex, fragile machines.
Yeah, definitely follow the patterns within Kubernetes and the reconcile loops. We've seen folks, use other methods and like things using config maps and then applications that don't restart and these sorts of things. If you embrace the operator model, you'll be much better off.
Cool.
So we have some resources. Tomorrow at 10:30 and 3:30, we'll be giving away the Managing Kubernetes book at the VMware booth if you want to stop by. In this talk, we only talked at the very high level. This book goes a little bit deeper on a lot of these topics. And we're happy to take any questions now.
Thank you.